Hello, this is Jo from Maths Tutor Me. Today we're doing indices and we're specifically doing scientific notation. Now, as you might be able to tell from the name, scientific notation is used a lot in science because in science you often have really big numbers and you don't want to have to sit there and write every single number in a massive big calculation. So they've come up with this, we've got this way of writing really big numbers in scientific notation. So that's what this first dot point is here. Scientific notation can be used to write very large or very small numbers as a power of 10. So to be in correct scientific notation, the decimal place should go after the first non-zero number. Now, large numbers will have a 10 with a positive power, and small numbers are going to have a 10 with a negative power. So let me show you how to do that. So let's write these numbers in scientific notation. So 754.6. We want the decimal point to go after the first number. The first non-zero number is the 7. So we want it to be 7.546. We still need to write all these numbers. Don't write the decimal point again. We've moved it to be after the first number, after the 7. Now it's going to be times 10, and the power of the 10 is how many places we've moved it. We've gone 1, 2 places to move it. So power of 2. Let's try that again. In the second one, we want the decimal point to be after the first non-zero number, the 1. 1.8. We don't need to write all those zeros after that. It's not going to do anything. So times 10 to the power. Now, where's the decimal point? I didn't have a decimal point to start with. So the decimal point is actually here to start with. Let's jump. 1, 2, 3, 4. 10 to the power of 4. Question 3. Let's do it one more time. We need the decimal point to go after the first number here, 9. 9.7308 times 10. The decimal point would be at the end. So 1, 2, 3, 4, 5, 6 jumps. 10 to the power of 6. In question 4 and 5, we have small numbers. Small numbers being that they are less than 1. This is when we're actually going to be moving the decimal point backwards. So we're going to have our 10s and they're going to have negative powers up here. So the decimal point needs to go after the first non-zero number. In this case, the 4 needs to go there. 4.57. It started here, so let's count how many places we've moved. 1, 2, 3, 4. So it'll be times 10 to the power of negative 4. For question 5, I need the decimal point to go after the 2, the first non-zero number. So 2.94 times 10. Now I've only had to move that one spot. So it'll be to the power of negative 1. In question 6, we have our first calculation. So on our calculator, on your calculator, type in 7,800 times by 300. And we get a big number, 2340000. Okay, now we need to put that into scientific notation. The decimal point needs to go after the first non-zero number, so it'll be 2.34 times 10, and then we count how many places we've moved the decimal place. It starts here at the end, so 1, 2, 3, 4. So for this next set of questions, we wanted to go in reverse. We have scientific notation, and we want to go back to the basic numeral, which just means normal number. So if I have a times 10 to the 5, that means I need to move the decimal place 5 places, making that number bigger. So I start with the 7. 1 jump would be over the 5. And then for the rest of the jumps, I need to add zeros. So I've done 1 jump, 2, 3, 4, 5 jumps, adding those zeros on. Let's do it again in question 8. This time, because it's a negative 3, I need to move in the decimal point to make the number even smaller. So I'm going to put the 8 2, and 9 down here. I'm going to need one of these to jump over the 8. 2, 3 will be zeros, and then my decimal point. So I started here, 1, 2, 3. Kind of a cheat or a check is that if you have scientific notation with a negative power, whatever the power is, so in this case is a 3, is the number of zeros that are in front of it, including the one in front of the decimal place. Right, question 9. Back to a positive, so we're making it bigger. We need 5, and then we start counting. We've got 6 spots. So 1, 2, 3, 4, 5, 6 when we run out of numbers to jump. And there it is. Okay, one more question down the bottom here. Now this is because you need to be able to type scientific notation into your calculator. So that's a big calculation. 7.1 times 10 to the 8 times 6.5 times 10 to the 4. Now you might not have the same calculator as me, so it's important that you learn how to use your calculator, but I'll show you how to do this on my calculator. For mine, all I have to do is type 7.1, and down the bottom I have this button that has a times 10 to the x on it. If I push that button, it does times 10. And all I have to do is type the power, 8. You don't need to do a power or anything up here with these buttons. You just type the 8 straight after it. Okay, then I'm going to go times, and I'm going to do the same thing again with this one. 6.5, my times 10 button down here, 4, equals. Okay, and my calculator actually put that in scientific notation for me. So my answer is 4.615 times 10 to the power of 13. So on the next page, it is practice time. So pause the video, have a try of these questions. They're just like the ones we just have done together, and restart the video to see how you went. So question 1, writing in scientific notation. The decimal point goes after the 1, 1.7894 times 10. We've jumped 1, 2, 3 places, so 10 to the power of 3. Question 2, the decimal point needs to come after the 7, so 7.96 times 10 to the power, let's see, 1, 2, 3, 4, 5 to the power of 5. Question 3, we have, this is the small number, so we want the decimal point to come after the 9, to go there, 9.7 times 10, and we jump 1, 2, 3 places, so it'll be a negative 3 because it was a small number. For question 4, the decimal point needs to come all the way down after the 4, so it will be 4, you could write 4.0, it's just 4, you don't even need to write a decimal place, times 10, we jump 1, 2, 3, 4, 5, 6 places, so negative 6. Question 5, we have a calculation, so on the calculator, 9320 times 32000 equals a very big number, but not big enough that my calculator put it in scientific notation for me. So I have to do that myself. The decimal point goes after the 2, 2.9824 times 10, 1, 2, 3, 4, 5, 6, 7, 8. Oh, power of 8. It's pretty big. Okay, questions 6 and 7, we want to put them back as a basic numeral. So a power of positive 3, I need to jump 3 places, making it bigger. So the 7 isn't one of the spots, but the 2 is one. So it's one spot, 2, and to do the third one, I'll have to add a 0. For question 7, I have a negative power of 6, so I need the decimal point to be moving this way, making it smaller. So I'll have the 9 and the 8, I'll write those down first. 1 will jump the 9, 2, 3, 4, 5, 6, and then the decimal point. Question 8 on the calculator, type in the scientific notation into your calculator. 3.7, the times 10 button, 14, times 1.8 times 10 button, 9, equals 6.66 times 10 to the power of 23. Now, I just put this question on the end here because I wanted to show you kind of an application of scientific notation. So we have a plane travels an average of 6,540 kilometers per day. How far will it travel in 2 weeks? Give your answer in scientific notation. So if it does 6,540 kilometers in a day, in 2 weeks, there is 14 days in 2 weeks, so I want to times that by 14. Okay, that's the calculation. 6,540 times by 14 is this number. And then I just have to write that in scientific notation. So the decimal point will come after the 9. 0.156 times 10. 1, 2, 3, 4 places I've jumped, so times 10 to the power of 4 kilometers is how many kilometers the plane will do in 2 weeks. Alright, so find lots of questions, practice lots of questions with scientific notation, and I'll see you next time. Bye!